This video is for Module 7 of CS33, Introduction to Data Structures and Algorithms Part 2. Okay, so we have 4 videos for the week. This is just the first video where we will have a short review of the basic concepts of computation, problem, and algorithms. The second, third, and fourth video will be examples of algorithm paradigms or algorithm design strategies. The easiest one, the brute force algorithm, or sometimes called exhaustive search, and then followed by transform and conquer, and then lastly space for time trade-off. Okay, so as a short review, let's start with the fundamentals. A problem or a computational problem is characterized by a pair of input specification and an output specification. Your first encounter of a computational problem is when you read the machine exercise specs with a description of the input and the expected output. So it could be in a paragraph form, but to be precise and to avoid confusion, formal definition of the problem is written using the language of mathematics. Now, to solve the problem, an algorithm is used. An algorithm is a sequence of instructions for solving a problem. Now, the set of instructions are valid instruction sets of a computer. In most cases, it's the von Neumann architecture of a computer that is based on a Turing machine. Of course, there are other computing models out there aside from the Turing machine. Ito yung mga quantum computers, probabilistic Turing machine, and so on. So as an example, we have the basic problem of sorting. So for sorting, the problem definition is expressed here mathematically using the pair of input and output. So for the input specification, a valid input for this problem is a sequence of n numbers, a sub 1, a sub 2, up to a sub n. So we know that meron tayong n numbers denoted by a sub i's. And then an output, which is a specification of the desired output of the problem, is a reordering of the input sequence such that this property holds. Okay, so this one is a formal definition of a problem, of the sorting problem, and of course are already existing algorithms solving the sorting problems. And of course, familiar na kayo from the previous courses that we have selection sort, insertion sort, merge sort, and many others. Okay? And of course, there are algorithms that are better compared to other algorithms. So, and all of them are running on a computer, which is the von Neumann architecture. Okay, so since CS33 is focused on nonlinear data structures, most of the problems that we will be solving for part 3 are graph problems. Here's an informal definition of a graph. A graph is a collection of points called vertices, some of which are connected by line segments called edges. So sa example natin dito, yung vertices natin ay yung mga A, B, C, D, E, F, and yung line segments natin ay yung mga lines connecting the vertices, so sometimes represented by a pair AC or CA if it's undirected. So graphs are used to model real-life problems, and here are some of the examples. Graph can be used to model the World Wide Web. For example, this is a Wikipedia representation. No? Each vertex ay page, and then there's a connection between one page to another if there is a reference between one page to another. And then it could be a model for a communication network. So if it's a communication network, the vertices here could be computers, smartphone, or some IoT device, and then there's a link connecting two devices if there's a connection between the two and the two devices can communicate. Graph can also be used to model transportation network, where if it's a train station. The vertices could be a train station, and then the edges could be train tracks. If it's a road network naman, these vertices could be landmarks, and then road connecting landmarks naman yung edges. Okay, so in general, graphs can be used to model the relationship of different entities. So for example, in a social network, entities could be the person or specific user profile, and edges are friendship connections. Okay, so here are some of the examples. There is a group of graph problems dealing with getting the shortest path. It could be as simple as a decision problem, checking if a node A is reachable from B, or identifying a shortest route or a path from A to B, or the classic problem called the traveling salesman problem, where we look for a shortest tour from a given graph. And then another example is the community detection problem, where we look for a subset of highly connected vertices. So, as an example of a community detection, the community detection problem can specify a subset of users in connivance kapag ka-fraud detection yung problem. It could be a group of collaborators in a research. What else? Could also be a group of interacting proteins or genes if it's a biological network. So, although there is no single recipe how to solve a problem, meron namang established process on how to solve a problem and how to design an algorithm solving a problem. So, it starts with understanding the problem. Equivalent kapag meron kayong ME or MP, what you need to do is to read the specs of the input, ano ba yung mga valid input, and then desired output. After understanding the problem, we need to do item number 2. That is to identify the capability of the computing device. So, yung algorithm mo ba magra-run on the phone? Magra-run ba on a computer? Magra-run ba on a parallel computer, high-performance computer? And then, the next item that we need to know is choosing between an exact and approximate solution. So if there is an easy way of solving the problem, then of course we wanted to know the exact solution. If we say exact solution, that's the optimal solution. And if we say approximate solution, willing tayo to sacrifice the quality of the solution kapalit ay yung running time. So it's also important to identify the design technique that is appropriate for the problem that we wanted to solve. And in designing the algorithm, sometimes we just need to follow the idea of the design strategy. After designing the algorithm and writing the algorithm in a pseudocode, we need to know whether the algorithm that we provided will provide the correct answer, and that is for item number 4, the proving the correctness of an algorithm. If it's correct, then analyze the algorithm with respect to time, space, sometimes may other metrics pa like communication, etc. Then the last stage is to code the algorithm. So, sometimes, yung ginagawa ng iba is to directly code the algorithm, which is not the correct way of doing it. So, after reading the problem, minsan dumediretso sa code ng algorithm. Wala namang problem doon, but of course, marami tayong hindi natitake into account, or probably the coded algorithm is incorrect pala, or the algorithm is not that efficient.